Hello, my name is Philip Penland. I am here teaching about equivalent fractions today, so we are going to go over a part of my lesson plan as this needs to be under 5 minutes. So we want to be able to get through at least the base understanding of what equivalent fractions look like. So I think we are all familiar with what a fraction is at this point. That is a part of a whole written out as one part over the whole. So 1/2 or 2/8 or any variation thereof. So when we have fractions, they are going to appear something like this. So here we have our 1/2. When we're discussing equivalency between fractions, we're talking about two fractions that take up the same amount of space, whether that is an occupancy of objects or the amount of parts of a line. And we're going to use a line here in a moment to discuss how we can view them as equivalents equally on paper. But when we look at equivalent fractions, we put two fractions together, we can ask, are they equivalent at sight? So 1/2 obviously is 1/2 of a whole, but 2/4 is a unsimplified version of 1/2, which means that it also equals the same amount. So if I have 1 part of 2, I still have 2 parts of 4. So these do show that they are equal, and the easiest way for us to really look at that is to look at number lines. So when we look at number lines, like demonstrated here, the top shows 1 through 10. We can see that 1/2 is equal to 5/10. So if we were to see 1/2 or 5/10, we would be looking at the same. Below that, we can see how on the number line, when we divide the part into halves, we can see that 1/2 takes up that much space. When we divide the line into fourths, we can see that 2/4 of that line also equal 1/2. When we divide it into sixths, we can see that 3/6 takes up the same amount of space. And finally, if we divide the line into eighths, we can see that 4/8 takes up the same amount of space. So all equal the same length on a number line. And obviously we can use bigger numbers than 0 to 1, and we were just using parts of one singular whole. So again, if we have 1/2 and 2/4, we are looking at a concept that equals two equivalent fractions. So 1/2 to 2/4. Now what happens if we multiply the numerator and denominator by the same number? So let's say that we multiply 1/2 by 2. When we multiply both of those by 2, we end up with 2/4. So if we multiply the numerator and denominator by the same number, we generate equivalent fractions, as long as we multiply the numerator and denominator by the same number. So now if we think about that in a context of if we were to multiply 1/2 by 3, so 3 to the numerator and 3 to the denominator, we're going to get 3/6. So 1 times 3 is 3 and 2 times 3 is 6. What about if we were to do that by 4? So 4 times 1 is 4, 4 times 2 is 8, we get 4/8. So again, we get more fractions that end up equaling the same value. So that would mean that 1/2, 2/4, 3/6, and 4/8 are all equivalent fractions. They all take up the same space on the line as we demonstrated here with the actual line. 1/2, 2/4, 3/6, and 4/8 all take up the same amount of space. So this is the easiest way for us to look at equivalent fractions. There are some models that I want to show you on the whiteboard shortly, but this gives us a frame for us to start with understanding how to use these fractions in real life.